as a planet, we are not short on energy. Until the last 20 years or so, we just weren't very good at harnessing it. The real reason to go into renewables is not, oh, we're going to stop climate change. The real reason is to get access to this energy, to have the lives that many of us get to take for granted, where we don't worry about daily survival, that we can self-actualize, that we can do creative things. All of those things are made possible by access to this energy. So if everyone on the planet had access to the energy that they needed, how would that change and how would that transform humanity?
Deb Chachra is a professor in engineering. She wrote a book called How Infrastructure Works: Inside the Systems That Shape Our World. World shaping is an underlying theme in her work. Society, culture, government, people, relationships. We go inside the systems she talks about and discover new ways we can shape our world. If I were to say, I met this most interesting woman yesterday. We had a great conversation. She's, what would you want me to finish the sentence with?
This is the thing I struggle with. The sort of default answer is that I'm an engineering professor. So I've been an engineering professor for a couple of decades now. The other thing that, depending on who you speak to, folks will say is that she wrote a book on infrastructure and thinks deeply and talks about infrastructure in lots of different ways.
You don't fit for me the image I have of a professor of engineering. You're so involved in culture and humanity and people and the past and the future. And I find that a really interesting framework that you're working in. And that's one reason I wanted to talk with you. That comes across very strongly in the book. I've read your book and looked at parts of it more than once. I think you've gotten good reactions to your book, haven't you?
I have, yeah. I feel like there's certainly people with whom it really resonates. And it's actually, the book came out 2 years ago and I still get, emails regularly saying, thank you for writing this book. And it really resonated with me. So it is genuinely delightful to hear from people. And I appreciate when they take the time to write. But that, it makes me feel like, oh, the book is finding its audience, right? The conversations it's having, it's going out in the world and having those conversations.
What led you to writing this book? What there must have been something that triggered it, or was it a progressive process?
There was. So you mentioned that I'm a little bit atypical as an engineering professor and that I'm not, the person who is in the lab and is kind of focused on one thing for the entire time. So there's a few kind of threads to it. So I mentioned that I was an engineering professor, but I've been teaching at an undergraduate engineering college and that I helped found and develop. So mostly I teach engineering, not sort of to graduate students and doing research at that level, but with undergraduate students and thinking and talking with them about understanding the world. So that's kind of one thread of what led to writing this book. The other is just that I've had a long-standing interest in infrastructure, in these sort of systems. So I grew up on the shores of Lake Ontario. My father worked for the public utility. And there's kind of a crew of people, of sort of friends, but also colleagues and researchers who've been thinking more and more about these systems over the last 15 to 20 years. And partly it's because they're coming into focus because of things like climate change. Partly it's because people are sort of interested in these larger systems. And so those kind of two pieces, sort of thinking and talking to engineering students and explaining kind of, I don't know if I want to call them basic, really more like fundamental concepts in engineering and how they interact with the world, and thinking about these sort of infrastructural systems that I've been sort of thinking about for literally since I was a child. So the two pieces kind of started to come together with the realization that I was really interested in these larger systems, but also I had a specific perspective on them because I was coming not just from kind of the social and cultural and political perspective that we all have, but that I could really leverage having that specific background in engineering and some of the ways in which that shapes my thinking about these systems.
One of the questions I wanted to ask you was, what are the ethical dilemmas that you think we're facing now, we as a global population, or that we'll be facing even more so in the future?
I've used the word infrastructure a bunch of times already. And I should say that I focus on infrastructural systems that are these networked technological infrastructures. So it's, what we think of as infrastructure, as sewage and electricity and water, telecommunications, transportation, all these kind of engineering. So one of the things that I think about as the key ethical issue at the heart of these systems is that almost all of them have been built with something of sort of mindset of utilitarianism, sort of mindset of we're going to benefit people, it's for the greater good, And often that means the goods of the many outweigh the needs of the few, right? And that really, really is the mindset that shaped a lot of 19th and 20th century infrastructure. It's like, well, we'll put a dam here and we will benefit from the electricity or the water control. And we're not going to think that hard about the people who are already using this land. Or, well, somebody has to live near the oil refinery, or somebody has to live near the highway, or somebody has to live near the container port. And it means that a small number of people will suffer so that our economy does well. That utilitarianist mindset, I think, has really shaped a lot of how these systems were built. What changed over the course of the 20th century and is sort of ongoing, is this idea that we can ignore some of the people or some of the places that are impacted has really changed. And like a large chunk of that was a political change. So things like civil rights. A chunk of that was just the fact that we live in a global connected world, right? There's no place where we could be like, oh, well, those other people that we'll never hear from are the ones that are going to have to deal with it. And we don't have to worry about it. And so that's really shaped the ethical contours of how we make decisions around these systems. I don't think there's sort of any, neat, good answer, but I do want to point out that when you frame it that way, when you say, oh, this is the implicit ethics that have been used for this, that opens up the door to think about other ethical frameworks. One of the ethical frameworks that I think and talk about is the ethics of care. And so that's using other more relational ethical frameworks rather than the sort of abstract calculus of some people benefit and some people harm. It's thinking about what people need, how do you know it's what they need, about, justice, about ensuring that everyone has what they need to thrive and the like. So to me, that is the deep, this is such a good question because it's not like, oh, it's a single ethical dilemma. It's a sort of deep underlying framework for how we think about and build these systems at all is an ethical framework and thinking about how we want to change that ethical framework.
One thing I found absolutely fascinating is when you said that the future of infrastructure should be a collective social project, and that it's not made by some highly paid organization, but it's something that people should be building themselves. And I put a little note in the document I sent you about the guy in Uganda that I interviewed, what he had the project Collect. He was an end plastic pioneer, and they built this little artificial village and where people could come and live and learn how to handle plastic. And so the community got involved. It was way beyond the typical telling people what they should do, helping them live what they should do. And they were making it a collective social experience, a learning experience. Now, you feel, I believe, strongly that that's the way it should be happening. I mean, from a collective viewpoint, from a learning viewpoint.
Yeah. So I'm going to back up a little bit. And so one of the things I want to stress is that all of our infrastructural systems, all of these network technological systems are intrinsically collective, right? If you have infrastructure and it's just you, that's like Little House on the Prairie, right? You're just homesteading, right? It's like, oh, well, we dug our well and we dug our outhouse and we built our chimney and all this stuff they talk about in Little House on the Prairie, right? It's homesteading. So infrastructure by its nature is collective. We have a shared water supply. We have shared electrical systems. We have shared networks. The question that then we get into is how do we interact with these systems? And then how do we make decisions about it? So there's a couple of pieces to it. So one is a lot of the infrastructure, if you live in a place that has kind of full stack infrastructure, right? So that you have reliable electricity and clean water and sewage and waste and recycling pickup and all those things. These are built out as collective systems, right? They're sort of the decision-making piece might be technocratic, it might be participatory, but we've built these as collective systems. Infrastructure is intrinsically collective. The thing that I think that is in the sort of moment of change that we're trying to figure this out is weirdly, well, maybe not weirdly, it's a thing that is really driven by technological changes. And it is that all of these systems run on energy. And this is where I said, it's like, oh, I come into this as someone who's an engineering professor, right? It's like, economists think that the world runs on money. Many of us think that the world runs on money. If you're an engineer or a scientist, you understand that the world actually runs on energy. And the shape of the last 150 years or so, the Industrial Revolution, has been that most of that energy has come from fossil fuels. It's come from combustion. But thermal generation, right, getting energy from combustion, getting it from heat, has certain characteristics. And one of those, for example, is that the larger the system it is, the more efficient it is. So it makes a lot more sense to build a single large coal plant to generate electricity. It's much more efficient. It uses less coal. It's less polluting than it would be to have many small plants. That logic is no longer true if we're not using combustion. And renewables, by their nature, generally do not go through thermal generation. There's a few exceptions. But solar and wind, for example, don't involve setting anything on fire, right? So the thermodynamics, the actual physical characteristics of how do we get energy from heat don't come into play, right? They're working in a totally different way. And what that means is it opens up technologically the ability to decentralize energy generation. And so that's a real shift. So historically, we did all of our energy generation locally, right? You had your own stove, you had your own heater, and so forth, right? And then we moved to specifically using electricity, but generating it in these sort of centralized sources. And if you've ever been to places like London, you've seen the Tate Modern and the Battersea, the one that's on the cover of the Pink Floyd album, right? That were the big generating stations in the city of London that were sort of large centralized systems. So what this opens up, if we don't have the same technological reason to build large systems, and we can say, well, now we have the opportunity to build small, decentralized energy generation. The real question to me is, how does that change the social structures around these systems? How does it change the political structures around these systems? How does decentralized energy generation change politics? So when we think about collective and participatory, a lot of it is a question of scale, right? So it's intrinsically collective. We're all in the network. We're all sort of in the landscape. We've been doing things with some very large scale systems because there's been good reasons for us to, from an engineering or technological point of view. If we open up this sort of whole new world of generating energy that isn't required to be centralized, right? It's still collective. It's still a thing we're doing together, but the scale on which we're working might be somewhere in between doing it as a household or a homestead, right? The idea that I'm going to generate all my electricity, and at the other end, having these sort of huge, huge, huge systems. And so when we think about, nuclear plants, or we think about the Hoover Dam, or if we think about these sort of large coal stations, right? The 20th century was really driven by the sort of the scale, but now we've sort of opened up the space in the middle, and we're in the middle of exploring what that might look like.
What do you think that will look like?
We're still figuring it out, right? I know this podcast is imaginizing about the future, and I think it is definitely one of those things where, any one of us, this is not a thing that it's like, oh, this is what I think will happen. But here's, some pieces of it are certainly the other side, right? The other side of this driver is that we all, know that we are now living the impacts of climate change. And the nature of anthropogenic climate change, it is precisely that it is unstable, right? That it is like the sort of past performance does not predict future performance. And if we build these large scale systems, if we build these networks that go through the landscape, that bring resources to where we need them, that could be water, that could be supplies, that could be fuel, that could be energy. If that landscape itself is changing, right, that we can no longer take it for granted, that the way that it's behaved in the last 10, 20, 50, 100 years is the way it's going to behave in the next 10, 20, 50, 100 years, then that means that we do need to rethink these networks that are embedded in that landscape, right? If the landscape is changing, you can't take it for granted that those networks are going to work anymore. And so one piece of climate resilience is thinking about, okay, well, we're not just going to build these sort of large scale networks and assume that nothing is going to change, right? So now we have one of the opportunities that arises is that if we're thinking about other ways to generate the energy and share the energy, is doing it on a different scale, so that it's not just about moving it large distances across a network that's changing, but it's also about making things more resilient, right? If you're generating energy closer to where it's used, for example, it makes you more resilient to different kinds of change. If you are in a microgrid where your local energy generation is basically stays up, even if it's not connected to other areas, then it means that if there's some kind of disruption, it means that your local area can still have energy. What's even better is that if you network together smaller areas that have energy, then they can share energy with each other. So instead of it being sort of a top-down delivering it, thinking about this as, well, we can both generate it locally, we can share it in the sort of federated, networked way, and we have a reason to do that because we know that that's going to be more resilient in the face of climate disruption, in the face of sort of anthropogenic climate change. So whether that's extreme weather, whether that's things like wildfires, right? Or whether it's just kind of day-to-day making these systems more stable. And that, to me, is kind of the real change that's happened between the 20th century and the 21st century. I mean, it's a little bit of a sort of a carrot and a stick, right? That we know that the systems we have, even if they work well today, right, are predicated on this sort of constant landscape, right? If we're moving things from far away to where we use them, we're sort of assuming that everything in between is going to be sort of predictable. And that's not really true anymore. But at the same time, we have this real new opportunity to rethink these systems, to think about the scale that we want to be working on. And that scale might not be as large as possible, which it kind of was in the 20th century. It might be, what is a more local neighborhood resilient scale? And this ties back to what you said, is it's changing our relationship with these systems, right? That's a little bit less, oh, there's this giant system. That's a little bit more, we're in a relationship with the people around us, but at different scales.
How can you get this idea across to people? I mean, this is for me, it's a critical question. How can you make people see it as something that's, how would I say, practical and doable for them, and not just doable and practical, but beneficial to them? If they don't see it themselves, or they're not living it, how can they understand it?
So I don't think there's a one-size-fits-all answer to that, because I think that the nature of how we use energy and infrastructure is highly variable depending on where we live and the types of systems that we are in right now and where energy comes from. Right. So that's the first piece of it. I don't think there's a one-size-fits-all answer. I do think there's a few key pieces, right? So one key piece is the idea that we all want our infrastructural systems that meet our most basic needs, that give us energy and agency to act in the world. We all want them to be reliable and resilient. We all want to be able to not take them for granted, but to understand that they're there for us to use so that we can do all of the other things that we want to do with our lives, that are not, making sure we have clean water to drink, that are not worrying about how we're going to heat our home or have light to work by. So the first piece of it is, how do we build systems that are reliable in the 21st century, in the era of climate change, right? So the first piece of it is, what do these systems look like if we want them to be resilient in the face of climate disruption? The second piece of it is kind of backing up one step, right, to why do we want to go into renewables? And so I've said it has some affordances. We sort of went straight into the collective piece. So I said one thing about renewables is that it allows you to have decentralized energy generation. Instead of having sort of big plants, you can have small plants, and why that might be valuable. But the larger reason why we want to go into renewables is not just because we'll solve climate change, right? The reason why we want to move to renewables is because we are used to thinking of energy as something that is scarce and expensive.
Yeah, that was a really strong point in the book.
Because that's been the case throughout all of human history. It's mostly been the only way you can get energy is by setting things on fire, right, through combustion, and then turning that heat into something useful. There's actually been a few useful exceptions, right? Water wheels have been around a really long time. Sailboats have been around a really long time, right? But broadly, if we wanted to get energy to do things useful, we did it through heat, through combustion, through setting things on fire. There's a few things that are so challenging about this. So one is the one that I already alluded to, that because of the nature of turning heat into other things, it benefits from being centralized. So there's a sort of impulse to make things bigger. That's not the real problem. The real problem is it's not very efficient, right? So it means that you need a huge amount of energy to do the new thing. So that's a problem. Another problem is that you have to get that energy from somewhere, those fossil fuels from somewhere. And, the difference between having a car and having a bicycle is that if you have a car and it runs on gasoline, every time you turn the ignition, you're paying for it, right? You're paying for it at the pump. You have all the operating costs of having your car, right? But you also have this sort of incremental cost, right? That if you use it at all, you have to have money for gas. Mm-hmm. If you can contrast that with things like a bike, right? If you have a bike, you have to pay to have your bike and you pay to keep it in good condition and so forth. But you can just get on it and ride, right? You don't have to think about, do I have, is it worth spending the gas? Do I have money on gas? And so renewables functionally have the opportunity to behave like a bike, not a car, right? That once you build the system, you have all the same operating costs and all the same distribution costs, but you don't have that incremental cost. And this is why I already mentioned the Hoover Dam. I grew up near Niagara Falls, right? It's why people looked at these huge waterfalls and immediately said, as soon as it became possible to convert movement into energy, right? To say, well, we have a water wheel, but now if we hook a water wheel up to a generator, up to a dynamo, we can produce electricity. People immediately were like, we're going to do this because that input energy is free. You don't have to pay per per gram, so per kilogram of coal. You don't have to pay per input joule. And you certainly don't have to pay someone somewhere else to get the coal or to get the oil or to get the gas. The second piece of going into renewables is to change the economics of how we spend money to get energy. And that is actually enormously powerful, right? So you can think about things like energy independence. You can think about, you may have heard that data centers, for example, are often located near hydroelectricity because it's like the most inexpensive electricity around. And it's like we, the rest of us also want that inexpensive electricity to do things. And so one big argument for going into renewables is that it means that all of our energy could conceivably behave with the same economics of hydroelectricity, whether it's hydro or not, right? That's true for solar panels. That's true for wind, right? That's true for all of these sources where you don't pay for the input energy and you make use of the specific resources that you have around you. Every place is either windy or sunny, or has waves, or has geothermal, or some, more than one of the above, right? There's no place that doesn't. And then the third piece of this is that, again, we're used to thinking of this as scarce and rare. But if you run the numbers, the solar energy that's coming to our planet, basically, if all humans used energy at the rate of North Americans, which is, among the highest in the world, if everyone used it at that rate. And so think about all of the things that you do with energy, right? So transportation and telecommunications and light and heat and cooling and all those things. If we used it at that rate, but globally, that's still a fraction of a percent of the incident solar energy, right? So as a planet, we are not short on energy. Until the last 20 years or so, we just weren't very good at harnessing. And so to me, one of the real pieces of potential, the real reason for me to go into renewables is not, we're going to stop climate change, right? The real reason is to get access to this energy, to have the lives that many of us get to take for granted, where we don't worry about daily survival, right? Where we don't worry about how we're going to cook our food. We don't worry about where our lights come from. But it means that we can do other things, that we can have relationships with each other, that we can self-actualize, that we can do creative things, right? All of those things are made possible by access to this energy. So if everyone on the planet had access to the energy that they needed, right? How would that change and how would that transform humanity?
Would it make a difference in climate change?
Well, so here's the thing, right? So it's like if we do that, it will solve climate change on the way. So I mentioned at the beginning that I teach undergraduate engineering college. And so I spend a lot of time with 18-year-olds who are smart 18-year-olds who look at the world and they understand that things are not in great shape, right? That things are not good. If you say you're going to spend the rest of your professional life dealing with the problems that the people older than you made, and your job is to backstop it and keep bad things from being worse, right? That is very, very different than saying that the thing that you get to do is kind of the same thing we did a century ago, which is take advantage of these new technologies to have access to energy in a way that's unprecedented, right? To use that energy to start mitigating the harms to the environment, right? To use the energy to start dealing with the fact that there's carbon in the atmosphere. One, to stop putting carbon in the atmosphere. Two, to start thinking about ways to use that carbon in better ways. Three, to build a more equitable and just society, right? That's what we're after. We're after building that world.
And do they respond to that?
Yes. Yeah. And it helps because it's true. This is not like science fiction, right? You're going to be doing all the same hard work, right? Don't get me wrong, right? None of this is going to be easy. But the difference is that the goal is not to keep bad things from happening. The goal is to actually create this better world and deal with the bad things on the way.
I wonder if some of those kids go home inspired by what you're talking about, talk to their parents about it, and find themselves in contradiction with their parents who don't necessarily support that sort of conflict between generations. Do you think that happens?
I don't know if it's really a conflict between generations. I mentioned that for all of human history, energy has been scarce. And that was actually true for most of my lifetime. It was not true for the lifetime of my students who are undergrads, right? But both of us, right? We didn't have access. We didn't know how to access renewable energy in the way we do now. I mean, there was a huge concerted effort to figure out how to reliably and economically access energy. So part of that was solar panels, right? Getting highly efficient solar panels out of the laboratory and into the field, right? And the other one was the now ubiquitous wind turbine that we see everywhere with the three vanes, right? That was a private-public partnership out of Denmark. And that to build this sort of very reliable turbine that can work in a variety of circumstances. And so when I was an undergraduate engineering student, those didn't exist. The only way that we could get the energy to do the things that made our lives possible was through fossil fuels, right? And so this is why, for Americans of a certain age, or those who've sort of learned about this might remember Jimmy Carter in the oil crisis saying, oh, you should turn the heat down and wear a sweater, because the only way you could reduce your fossil fuel usage, and therefore the only way you could reduce your carbon outputs, right, your carbon dioxide outputs, was to reduce the amount of energy you use, right, to turn the thermostat down. And that's what's changed. So I don't think it's a generational conflict. I think it's just that as a society, as a community, as a civilization, we haven't internalized what moving into renewables and decarbonizing opens up to us. So I think of this less as, well, we need to decarbonize, so we need to build these systems that let us decarbonize, and more that, okay, we need to keep our eye on the big picture, right? And the big picture is a world where we don't have to go through moving carbon atoms from under the ground to the atmosphere in order to get the energy that we need, right? And what does that open up for our lives? And what does that open up for how we can deal with remediating the environment that we're in? And how does that change the relationships we have with each other in terms of being equitable or being just, right, in terms of mitigating the harms? I know I started with sort of infrastructure and sort of sewage and water and all these systems, but all of them run on energy, right? They're all how we collectively meet our needs, but they all need energy. So there's no way to think about them without thinking about what becomes possible when we move away from passing through combustion as a way of meeting our needs.
And if I understand you correctly, we don't know all the answers yet. We're looking for the answers. That reminds me, Deb, of David Weinberger. I've read a lot of his work, and he has the concept of unanticipation. It's the way we need to live because we cannot anticipate what's going to happen. So we need to leave open as many possibilities as possible, which enable us to go the direction we need to go when the moment comes.
Right.
And I think the idea of unanticipation is a strong idea. I have a feeling you agree with that.
There's other ways of looking at it. So Ursula Franklin, who is a thinker who gave a series of public lectures called The Real World of Technology, she talks about this idea of reversibility. It literally came out while I was an undergraduate engineering student as part of a national series of lectures in Canada, the CBC Massey lectures, and it's now available as a book. So she had a number of heuristics for technologies for these systems. And one of them was this idea of collective benefits, right? Systems where the benefit accrues to sort of everyone collectively. But one of them was specifically this idea of reversibility, that if you're building out a system, that you don't just build kind of giant top-down systems that be like, whatever, it'll be fine, is that you build out systems that you can build them out incrementally, and then you can see how they work, and that you could reverse them. I mean, I have to say, it's hard to imagine thinking this way in 1989, and I certainly read, that's when I first came across her work, and it percolated in my brain for a really long time. But we are now in the world where this is really key for a bunch of reasons. So one is the point I already made about, I understand why you want to build a giant nuclear power plant, right? Because it changes the economics and the efficiency because it uses heat. That's really different than if you're putting out solar panels. That's really different if you're putting out wind turbines or other systems that don't pass through heat. So those systems lend themselves to doing them incrementally, doing them in small scale, doing them sort of a bit at a time. But that also means that it gives us a chance to understand what the impacts are, right? So we don't have to feel like we have all the answers ahead of time. So it's not so much about unanticipation, it's getting away from having a false certainty, right? And into being like, we understand something about how the world works, but we know we don't understand everything about how the world works, or what kind of impact these technologies will have, or how people will be impacted by them. I mean, moving away from that level of like, we have all the answers that you might have had if you're an engineer in 1950, right? And like, no, we do not have that sort of level. We understand that there's lots about the world that we don't understand. And some of it is physical, like the impacts of climate change. A lot of it is social, right? None of us would say that I know how all these other people are going to be interacting with these systems. I don't, right? If I was an engineer in 1950, I could ignore that, right? I could be like, well, of course we have all the answers. We're the engineers. We have all the answers. And in retrospect, it's kind of hilarious, right? It's like, you were a very limited demographic of people who thought you understood how things worked for everyone else, and you really didn't.
Deb, do you think the legal profession has a role to play here, in that there are things that big companies are doing that are negative for the environment? Perhaps they need to be stopped or slowed down in some way on a legal basis.
Yeah, so I this is where it's really important to say, like, I'm not a policy person, right? There are many people who are like deeply engaged in that piece. The piece that I am going to say, I'm going to pull this concept from economics, which is actually two things I want to pull. One is the idea of externalities, specifically of negative externalities, right? So if you're an economist, there's the things you pay for and the things that you don't have to pay for, right? The things that go out in the world. And a lot of things are negative externalities where you can benefit from things, and if you're a company, you can benefit from things, they show up in your bottom line, right? But there are negative impacts of the things that you're doing, but you don't have to account for them. And mostly we think about this in the concept of the sort of harms it has on communities and the harms it has on the environment, right? These things where it's like, well, we produce this thing and now it's in the environment, but we don't have to pay for microplastics, right? You sold the plastics, right? But you're not responsible for the negative externalities, for the harms that are due to the environment, because plastics are getting into your environment. And so there's absolutely a piece there that needs to have this sort of alignment of who's benefiting, what are the harms, including the non-monetary harms, right? Most of these can't be measured in dollars. And then how do we make decisions about them? Right. And this is where, lawyers and regulation comes in, right? I'm old enough to remember the ozone hole, right? And that was 100%, right? A decision is like, well, we have technological alternatives to these things, and we are going to regulate the chemicals that are damaging the ozone holes so that they don't do it anymore. And now we don't, we have a much, much reduced ozone hole. And, when things work well, when regulation really works, we tend to forget that it ever happened. Right? Taking sulfur out of coal plants, right? It was causing acid rain, right? Was a regulatory decision. So because these systems are social and collective and political and economic, not just engineering decisions, then we're going to address them using all the tools that we have at our disposal, including sort of regulatory tools, right? Including lawyers. I mentioned that there are two things, right? So one is this idea of negative externalities, that many of the benefits, by the way, are also not things we can put a dollar value on, right? How do you put a dollar value on knowing whether or not it's going to rain for your kid's birthday tomorrow? Right? How do you put a dollar value on having light, right? Or electricity in your home? But the other piece of it is that we know that the impacts of these technologies and these systems goes beyond any of our lifetimes. And it's really difficult. Corporations are not set up, right, to think about impacts that might happen to not just the people who are there today, but to their children or their grandchildren or from faraway ancestors. And we don't capture that. Right? That can only be captured in collective ways that are civic. It's very, very, very challenging to capture that, in any company's bottom line. I mean, frankly, corporations are never going to care about your children, much less your grandchildren, right? But we collectively can decide it's something that we care about and figure out the systems that enable us to do that.
Are you familiar with the Long Now Foundation?
Yes. Yeah.
They are trying. I'm a member of it, but because I don't live there, a lot of their stuff happens in person. And so it's not as exciting. I watch the stuff online, but I can't go to any of the sessions. And they're doing great things. I know some of the people there. Are you a member of the group?
I'm not a member. I certainly know their work. I love that you saying it's not as exciting to not be there. It really highlights the fact that we are gregarious primates. Right?
Yeah, exactly.
Right. That it really is different to us to be in association with other humans than it is, even to be doing things online. And I think that's actually really, so I'm an immigrant, I'm a child of immigrants, right? And I think it's really important that we live in a global culture where we get to interact with people all over the world, right? I know it's really easy to be like, well, I'm never going to fly again, right? That's a thing that has a huge impact on your personal carbon footprint. It doesn't change. All civil aviation is 5% of carbon emissions, right? It doesn't change things in the larger sense. But I think the ability of humans to say, I have empathic, caring relationships with people who live in different places, who don't look like me, who have different lives than me, I think is really critical to addressing, right, these global challenges. I think it's a really important to understand that humans really need to be physically with other humans And that
Yeah.
could be in your city. So it could be building transportation networks that allow for personal mobility, to go to church, to go to school, to just hang out with people.
Yes.
But I also think that's true at the larger level, if particularly since we want to get away from the idea that people on the other side of the planet are different than us. And it's okay if they are the ones who deal with harms. And the power of being with other humans and recognizing that we are all humans is, hard to underestimate. And certainly it doesn't really make sense to deny.
What piece of advice would you give to the next generation?
So I implicitly do this all the time. So there's a few things. So one is this idea that the thing we're trying to do is we're trying to build out this new world. Next generation, your job is not to fix the problems of the grown-ups. Your job is to actually build out this new world. And in so doing, you'll fix the problems of the grown-ups. And I should point out that my advice to those of us who are grown-ups is you don't get to slough it off on everyone who's young, right? You don't get to say it's the next generation's problem, right? It is all of our problem, right? And we get to empower the young people to come and do that work, but we also have to do the work.
Yeah.
The other kind of corollary to that, and the thing I specifically tell my students, is these, infrastructural systems and our energy networks, right? These technological systems are the biggest systems that underpin our lives and what we can do, right? They're so big we can barely see them, right? We don't even think about electricity or energy or fuel. When we look at them at all, we say, oh, they're intractably large. So one of the things I tell my students is that there's no one right way to make the change. There's no one right timeline to make the change on. Some things are like, we need to do this today. Some things are like, we will still need this in 10, 20, 30, 40, 100 years. So it could be going off and doing your PhD and doing research. It could be, I had a student who literally left engineering school to join an Extinction Rebellion type group, right? Basically, he felt the really important need to do the thing today. And we need all those things. So the other thing I tell my students is that there's no right way or wrong way to think about this change and what to do. But it does make sense to think about what is the thing that you can do well? What is the thing that you can do sustainably and do that? Because there will be no shortage of worthwhile, meaningful work for this transformation.
Can you think of, in what you're talking about now, over the future years, like 20, 30, 40, 50 years, can you think of a major change in technology that would really make a difference?
So I sort of push hard against we're waiting for the new technology to come in, right? I definitely think much more in terms of actually, so first of all, I think that the major technology has come in, right? And, that line about the best time to plant a tree was 20 years ago and the second best time is today, right? And it's like 20 years ago, we didn't have the technologies we need to do this, right? 20 years ago was not the best time to do this work. We didn't have what we needed to do it. So I tend to push back against we're just waiting for like fusion or we're waiting for better batteries, right, to do this work. I think that we're at the beginning. This sort of goes with the unanticipation idea, right? We are at the very beginning of this sort of massive technological transformation. We're at the very beginning of rebuilding these systems. We have enough answers that we know that it's possible to do it. We don't need to wait for like the one perfect technology because we don't even know what the one perfect technology is, right? We just need to start, and we are starting, to be fair, right? And recognize that, really the limitations right now are not technological. They really are the sort of social, collective, regulatory, economic, right? How we make the decisions about allocating our resources. It's not even like, do we have the money, right? It's like everyone has sort of established that responding to climate change and building out these renewable systems and the economics of them, right, is like, it's all there in the sense of it makes more sense. It's redistributing the wealth that we have. It's not, we don't have the money to do it. But figuring out how to make those collective decisions, including, funding the research to allow us to continue to develop technologies in this space is absolutely the work. I'm not waiting for like the one transformative technology. I know if we continue to work and fund research that transformative technologies will come, but I'm in an unanticipatory mode for that. And I am in the anticipatory mode of we can build on what we have and grow that out.
How do you see your personal career evolving? By personal, I mean your individual career evolving over the next 10, 20 years.
So, speaking of being unanticipatory, you happen to have caught me in transition. So, I'm currently on leave from the undergraduate engineering school, Olin College, that I helped found and that I've been at for essentially my career. And I've relocated to the country where I grew up, which is Canada. So, I'm currently in Vancouver, BC. And I have a courtesy appointment at the University of British Columbia so that I have folks that I can talk to, that I can be part of a community here. But I really am kind of personally in transition in terms of what I want to be doing. And I know that I'll be building on all the work that I've done. One of the reasons why I'm actually on leave in here is because I'm really thinking hard about the problem of materials. And so the way I think about this is that, the energy transition, for all the reasons we talked about, right? The value of it, the economics of it, being decentralized, the sort of political response, all of those makes it really powerful to move to renewables. And one advantage of moving to renewables is that we're going to stop taking carbon atoms out of the ground and putting them into the air, right? We're going to stop moving them around. But the thing that we have historically done every time we've gotten access to more energy, so if we get abundant renewables, is that we just extract more and we consume more and we dump, right? The thing that is now possible if we have access to renewables is to use the new economics of renewable energy to start for real closing those material leaks, to start saying we want every atom that we've used or every atom that we want to use to basically to reuse it. So one of the questions I get asked a lot is like, well, what about lithium, right? What about plastics? And part of the answer is we should never have to take things out of the ground twice. If it's already out of the ground, we should be able to use those atoms again. And that piece of it, the why we don't think about it that way, I think is really closely tied to the fact that just like we don't see infrastructure, we don't see materials. Our understanding of the material world is really tacit, and we don't think about it. We don't talk about it. We tend to downplay working with our hands in favor of kind of working with our brains, right? There's we'll just like upload our brains, or like AI will solve everything. And it's like, no, we all have physical bodies and we live in a world of matter and energy. And I think those are related. So that's kind of where what I think I'm going to be focused on for the nearish and possibly the not so near future is this transition, not just to energy and to abundant energy, but the real cultural and sort of mindset change to use that access to energy to think differently about how we use matter and material, right? That we live on a snow globe, right? We have all the energy, or a terrarium, right? We have all the energy we need, but we are a closed system for matter. And we historically have treated energy as scarce, and we've been pretty, do what we want with matter. And we are absolutely hitting the physical limits of that. So thinking about what it would take to create the deep cultural change to use access to energy to start dealing in earnest with matter. And a lot of that is recognizing that we are in fact physical beings in a physical world and thinking about that seriously. So I think that's where my head's going to be at for the next little while. But the larger role that fits in, I think is an unanticipatory mode for me right now.
That's very interesting. Very interesting, Deb. You're onto something there, I'm sure. Do you have anything you'd like to add to our conversation?
Just thank you for having me on, right? Like the idea of imagining the future is obviously really the heart of what infrastructure is, right? That we build these collective systems that have never existed before because we think they're going to create something better for us. And it's really especially important now, right, to think about these technological systems and this transformation and what could be possible. So I think imagination is such a key part of that, of thinking different ways of thinking about a collective future.
I've really, really enjoyed this conversation, Deb. Really,
Thank you.
A lot.
Yeah, it's been great. Thank you so much.